kind of seeing what that looks like. So we'll do number 3. We can add to this if you guys want. So I'm gonna yes.
Can you go over how or which sides of the triangle sin, cosine, tan uses?
Yeah. So, we need our SOHCAHTOA to remember which one sine, cosine, and tangent goes with, and that will come up in this first one here, but I'll address that kind of in a second here. So they wanted the tangent of 2 pi over 3, and maybe it's worth us even doing sine and cosine of that. So those of you guys who are gone or didn't complete this, feel free to do this with us now. So again, until you're super comfortable with it, I'm okay with you guys switching over to degree measures instead. It really doesn't take very long to do that because you just might be more comfortable with that. It's just going to be pi is going to be on the bottom to get that to cancel. So this is the same thing as the tangent of 120. And that took me all of how many seconds? Yeah.
Throughout this entire thing, I was confused which one was the adjacent, which one was the opposite.
Okay, we'll talk about that. We'll address that right now, and we'll kind of bring that up again here in a second. So like how to determine which trig ratio goes with which. So when I go to draw this, I want to draw this in our coordinate system. It goes 0, 90, 180, 270, because we go counterclockwise. So I go 90, I'm past 90, I go basically 30 past 90. And so one of the things I do is I'm headed towards 180, and I think 120 is 60 short of 180. So this is going to be a 60-degree triangle here. Are we okay with that? Getting that reference angle drawn is probably the most important part, that if you don't get that, the rest of this, there's kind of no chance of knowing what triangle we're talking about here. Now I'm going to label this as the 30, 60, 90, and so that's 1, square root of 3, and 2. Now the shortest side is the 1, and that's always across from the 30-degree angle, so that's here. However, since I'm going to the left, it's going to be negative. Then the square root of 3 is usually the middle length side, and that's going up, so that's going to be a positive square root of 3. And then the hypotenuse is always positive, and that's just 2. Are we okay with that setup? Now at this point, so this kind of goes into both your questions. How do I know which side is which? We're using this reference angle. So based off of that 60, I'm going to label this triangle. Across from it is the opposite side. The hypotenuse is always the hypotenuse. That's across from the right angle. And then the adjacent is usually the leftover. But in this one, it's always the one on the axis, on the x-axis. So it's always going to be like that horizontal line. So it kind of helps in this case because of the way these are set up. So if I'm doing tangent, tangent is O over A. That just means opposite over adjacent. That gives us that acronym there. So tangent of 120, technically I'm doing tangent of the 60-degree angle, which seems kind of counterintuitive, but it's the same angle, is going to be opposite over adjacent. And dividing by a -1, I can just call that the negative square root of 3. You can leave it this way. I don't mind that as an answer. Either one is fine with me. Just because of some of those questions, should we do another one that has a triangle like that? Should we do number 4? Would that be helpful, Cash? You want to see another one? Or Sam, you guys?
What about number 5? Because like 2 of the sides are the same length.
Oh, yeah, let's do number 5.
What reference English would you use there then?
Okay, yep, we'll talk about it. All right, so let's do number 5. Kind of a strange one. So this one's the tangent of -7 pi over 4. Again, if you like leaving it in radian form, that's fine. Like I said, it's something that I probably switched it back all the time as a student, and then when I became a teacher, finally was okay with leaving it. To me, it doesn't take that long to do this. So this is a negative 315, I believe. So, negative angle. We're going to go around the other way. So we're going this way. So we're going 90, 180, 270. So we have to go counterclockwise. Now at 270, we have to go past 270, but not quite to 360. And again, hopefully you're realizing it's either going to be a 45-degree angle, a 30, or a 60. And so when we're working with these fives, typically it's probably going to be a 45, because this is 45 degrees past 270. So again, I always go back to the x-axis. So this is a 45, 45, 90 triangle that we're dealing with here. Now in a 45, 45, 90, we learned that it's the leg, and the leg squared to 2. We're just going to call it 1, 1 squared to 2. It's a unit circle, so we're considering it to be 1 there. Now at this point, I'm talking about tangent, so that's TOA. Now again, I need to label this triangle. So again, from this angle, we have our opposite. Again, our adjacent's always on that axis. And then our hypotenuse is always the diagonal one in its perspective. In like every quadrant, that's always going to be the hypotenuse. So in this case, the tangent of a negative 315 is the opposite of over the adjacent, O over A, so it's just 1 over 1. So that's how we just end up with 1 there. Now, if I wanted to know sine, it'd be opposite over hypotenuse, it'd be 1 over square root of 2. Same thing with cosine. All right. Is that feeling a little bit better, those of you guys who have questions still? Like I said, we'll do some more practice with this today. I think that'd be an okay thing to do some whiteboards and maybe take them outside and work through that a little bit as our practice. I definitely want you guys to be comfortable with this. Something you do use when you guys go to calculus, if you take trig, you guys will use it, but I don't want you to, I don't think it's out of line to kind of get it down, because once you've practiced it and get good at it, they're kind of logical, I guess, I think. But, all right. Other questions, or is that okay? So we haven't even touched the new notes from yesterday, so if you guys want to get those out, that would be great. So that was the one, like we just had done the warm-up yesterday. Does anyone not have them? I have a blank one. What I was going to talk about here is there's kind of just some things that are good to know about these trig ratios, that things are going to be helpful later on in this section. So, and just so you guys know, we're going to end up quizzing on just like this trig stuff, like rather than doing because we're still in chapter 2, but we had all those logs in the first half, so that's going to be a separate test just to kind of keep those things. I didn't want to put logs on this, so we'll do it like a trig quiz eventually. Probably, I would guess mid next week, I would think, kind of see where we're at. Because I know on Wednesday, no, I'm looking at the wrong week. Sorry, next week is up on the top row. I think we're okay. So like maybe Wednesday of next week we do a quiz on this. So we're only going to do a little bit more. This section 2A is a big section. I really could do like a whole chapter in itself on this, but we're not going to go that much more in depth. We just have a little bit more to do. So, I got a new computer, so like some of the settings are kind of weird, so hopefully. All right. So, one of the things I'm going to show you guys now is I'm going to write on this, kind of just letting you guys know an acronym that kind of helps us. So, I'm going to the way people remember this is lots of different ways, but like just like any acronym, like please excuse my dear Aunt Sally when you guys learn the order of operations, is kind of similar to that. I don't know, every teacher probably has a different acronym. The teachers that I had worked with, they use all students take calculus. So that has nothing to do with what we're using for this, but it's a way to remember. Now what this acronym is here for is to help us to know what trig functions are positive in each of those quadrants. So in this first one, and the way we do this, all students take calculus, we do it the same way we do our circle, where we go counterclockwise starting from 0. So the first one is obviously A, so that's all. It actually stands for the same thing. So that means all trig functions are positive here. So in that quadrant, all the trig functions are positive, and this isn't going to seem all that groundbreaking until we need it for something else. Now the next one does not actually stand for students, that's just the way to remember it. What do you think it stands for? Sine. So in this quadrant, only sine is positive. The other two are going to be negative. So sine is positive here. So that means cosine and tangent would be negative. And the way they're going to show that is they're going to write that's less than 0 a lot. So like greater than less than 0, so it's negative. So cosine and tangent are less than 0 there. All right, what do you think about lower corner then?
Only tangent.
Only tangent is positive. I know you guys are. So that means sine and cosine are negative here. And all students take calculus, then the C is cosine is only positive there. Now, because we have a little bit of space, hopefully you still have a little bit of space here, I did want to talk about those quadrantal angles right away again, just to review with you guys. So, kind of some special cases that show up with this is the coordinate points is always written as cosine comma sine. Now, if you ever forget which one comes first, you could be really simple and say they're alphabetical. Cosine comes before sine. That's one way to remember this. It's just we're so used to doing sine, cosine, tangent, so that's kind of confusing. But think of cosine coming first. Another thing to remember is in our triangles, cosine is always the adjacent side that we're talking about, so that's always the left and right one, so that's our x value. Whereas the sine is always our opposite, which is usually up and down. So it's kind of a good way to remember cosine is typically horizontal, sine is typically up and down. And then remembering that tangent is sine over cosine or y over x. So that, just kind of trying to remind you of those things. Another thing, like I said, to bring up is these points on the coordinate system, or like right on the axis. So like this point is 1, 0, and that's our cosine and sine. This one is 0, 1. These are the only ones I feel like I have a hard time just logically remembering until I have to think about it for a minute. So it's not as, because I don't have to draw a triangle. Now we're going to bring that up when we talk about this on Monday, because this actually gives us really strong connections to the graph. So on Monday we're going to talk a little bit about the shape of the graphs. You won't have to graph without a calculator, but I want you guys to kind of recognize some of the things about sine, cosine graphs especially. Tangent graphs are a little we don't need to get into them too much. They're a little bit tougher if anyone's actually graphed tangent in their calculator. Your calculator kind of goes crazy for a bit. So you all want to, I don't know, maybe you don't, but tangent is a little bit tougher to understand, but sine and cosine are kind of cool. We'll talk about those on Monday though. So much to look forward to. All right, so in this problem, actually, do you guys want to do whiteboards for a little bit now, or do you want to do a few examples? Well,
Let's do these two examples.
let's do these two just to get a little bit more notes done. Otherwise, we have a whole page of notes to do. Okay, that's a good plan. All right, we need to develop a plan. All right, so it says let the tangent of theta equal 5 over 12. Now these thetas, we've seen them a few times. It's just a fancy symbol for an angle. Why they don't just call x, I don't know. As soon as you pass a certain point, they start getting fancy. It's just, you don't have to know the name of it or what it is. It's just a little symbol. It always reminds me of a minion now, that we have, I don't know, little minions, I don't know. So tangent of 5 over 12, where sine of theta is less than 0. They want us to find the sine and cosine of theta. So I'm going to try and draw this, what I know about it so far. So the question is, do we know which quadrant this is going to be in based off of what we just wrote down? Yeah, it's going to be in the T quadrant. The reason it has to be in T is because tangent is positive. Do you see that? But sine is what? It's negative. So since tangent's positive and sine is negative, the only place it makes sense to be is in this quadrant, because that's where tangent is only positive and the other two are negative. So it only makes sense to put it in this quadrant. Now I'm going to draw it there. Don't let it throw you off though that I'm drawing it probably not perfect. I'm just drawing a right triangle. And once I draw it, then you might be mad at me for drawing it the way I did, because it's going to be lopsided. All right, where do the numbers go? What do we know? What's this telling us? Yeah.
Tangent of theta is 5 over 12.
And so what does that give us for this drawing?
It gives us sine and cosine.
Gives us sine and cosine. It actually gives us sine and cosine. Very good. Well, now that I say that, I don't know if I can say it gives us sine and cosine. It gives us something else. What does it give us?
Wouldn't that mean 5 is the opposite of 1?
Yeah, they're giving us the two sides. Sorry, I was quick to. They're giving us the opposite over the adjacent. So they're giving us the opposite over the adjacent, because of TOA. Little goofy TOA there, sorry. So if this is my reference angle, so our reference angle, kind of going back to Cash's example or question, this is our theta. The opposite then is across from that theta. This is 5, and then the adjacent's always on the horizontal, that's our 12. Now what am I missing about these numbers?
The hypotenuse.
We're missing the hypotenuse, that's one thing. What else are we missing? We're missing something else that I should have written right now. Why? Yeah, why should they be negative?
Well,
The 5 is going down and the 12 is going left, right? And the reason why it wasn't negative here, sorry, is because it's two negatives on top and the bottom. So they became positive because of the fact that we were dividing two negatives. Does that make sense? But Cash is right, we're missing the hypotenuse. So we still have to go back and find the hypotenuse. So we have 5, we have 12. Do we know how to find a hypotenuse? Pythagorean theorem, right? Now this is kind of going to show you why the hypotenuse is always positive. It doesn't matter if those two are negative. When I square them, they become positive. Now if any of you guys are good at your special right triangles, this ends up being 1. I didn't leave myself much space here. So C is 13. So our hypotenuse is 13, and it is positive because of the fact that we squared it and took the square root, and the hypotenuse is always going to be positive at least. Now we should be able to figure out the sine and cosine. Because now we have the triangle, we're in the right quadrant, we know where we are, so we're going to do sine of theta. Oh yikes, that's really thick. I have to fix all my settings in here. I have them all like set to the little skinny version, and they're not just going that way. So sine of theta, sine is so, S-O-H, so opposite over hypotenuse. And then cosine is adjacent over hypotenuse. So once don't do that. So once I have that triangle set up, finding those other two pieces aren't so bad. Why don't you guys try for a minute to try example 2. Don't lose your mind. If you're using pen and you want to wait for us, go ahead. We'll talk about example 2 here in a second. I'm going to take attendance and then get announcements of if we have them. See if you can figure out what quadrant we should be in. how did that go? Did you guys figure out the quadrant you should be in? It's like the big key is initially in the right place. Alright. So they tell me already the sign is what? Sign is positive or negative? The sign is negative. So if it's helpful, like we have all students take calculus. Whoops, that's not a C. No, don't do that. Oh my gosh. Just change that. All right, clearly a C. Okay, so sign is negative. So we already know sign can't be here or here, right? Sign is negative. But they tell us cosine is positive. And now the only place left that cosine is positive is that lower left or lower right corner. I know my left and my right. Lower right corner down here. Okay? Now if you're in the wrong quadrant, you might have gotten some signs wrong. But otherwise, the rest of it probably is still okay. Obviously, the signs are important though. So I'm going to draw this. And again, when I draw it, I don't think too much about which side is which. So if this totally bugs you that I draw it just as kind of like a 45, 45, 90, just to kind of keep it simple. But sine is opposite over hypotenuse. So my opposite is -1 over positive 5 or 1 over -5. So if I call the opposite 1, that's here, and then 5 is my hypotenuse, it's here, which one has to be negative? The 1, because it's going down. Hypotenuse is never negative, so you're going to assume it's on top. So we need to still find the adjacent, and then that'll allow us to find sine and cosine and tangent. Now this time, to find the adjacent, we have to do a squared plus b squared equals c squared, but this time we don't know a. Oops. All right, so a squared plus 1, nothing's working right, equals 25. So I move that 1 over, so a squared equals 24. And I take the square root of 24 and I get something about 4 point something. Okay. Now if we wanted to be really technical, we probably would simplify this radical. We'd call it like 2 squared to 6, but at this point I'm not worried about that. I'm just going to leave it the square root of 24. Now should this be positive or negative? Positive, so we're going to the right. So this is a positive square root of 24. Now I could use cosine and tangent. Cosine is CAH, tangent is TAO or TOA. So cosine of theta is adjacent over hypotenuse, so square root of 24 over 5. And then tangent of theta is this -1 over the square root of 24, right? Opposite over adjacent. But remember, we can't leave that square root in the denominator, so we have to rationalize this. So you have to multiply top and bottom by the square root of 24. Yikes, my board's not having a good time with me today. So it's the negative square root of 24 over 24. And it makes sense that tangent should be negative in that quadrant. Okay? All right. Why don't you guys grab